Okay, for the second part here of our section 4T, in the first part we talked about how to change numbers from other bases to base 10, and just to redo another example of that, if we had to do 3422 base 5 and we want to change that to base 10. So this is a number that's in base 5. Okay, we want to change it to base 10. We just want to recognize that it's going to work almost exactly like ours do with place values. So if we separate the 3, the 4, the 2, and the 2, and we put in our place values, normally for us we would have 10 here. Okay, it would be our 10's place, but for base 5 it's the 5's place. And normally we would have the 100's place, which is 10 squared, but they have the 5 squared's place, the 25's place, if you will. Okay, and then finally the 5 cubes place, if you will. And just like our normal adding in base 10, we would be able to evaluate each of these and then add them together, and that would show us what number this is for us in base 10. So if I do 5 cubed, that would be 125, okay, times 3, that would be 375. If I do 5 squared, that would be 25 times 4 would be 100, and then we'd have a 10, and then we'd have a 2. Okay. And then at that point, we could add all those together. We would get 475, 485. 485 plus 2 would be 487. Okay, so for us, the 487, our number 487, is equivalent to 3432 in base 5. Okay, so our main objective in this section is to just change from one base to another. Okay, for a variety of reasons, which we'll talk about more later. Okay. But the other skill that we have to look at, and again, this skill was illustrated in the first video, so hopefully you watched that like you're supposed to. Okay, the second skill that we're going to look at is what if we had to take that number 487, let's say that's in base 10, and we want to change that to base 5. Now, we already know what the answer is. The answer is going to be 3422 if we do it right. Okay, but the question is, how do we change base 10 to some other base? Okay, so the answer is as follows. You can do this in a couple different ways. Okay, I like to do it this way, and I would suggest that you do it this way. We're going to make it into a division process. We're going to take the original number, okay, and we're going to divide it by the highest power of the base that we can find that will go into the number itself. So I generally make a list right here going from right to left. I make a place value 5, then you'd have 5, and then 5 squared, then 5 cubed. And then the question is, how far do we need to go with this? We only need to go as far as the numbers that will go into the number in question. So if we put 5 to the 4th, that's 625. Does 625 go into 487? No, it's too big. So we only have to go as high as the number to stay lower. You want to go as high as we can, but stay under the given number. Okay. All right. So once we decide what that first one is, okay, in our case it's going to be 5 cubed, which is 125. And then we do a division over here, and we decide how many times can 125 go into 487. Okay, and the answer here is 3. And of course, you can use your calculator to help you figure that out if you don't know. Okay. And if we do 375 here, and then we subtract, we would get 112 as the remainder. Okay. All right, and then what we're going to do next is we're going to take that remainder and we're going to divide it by the next one. And the next one for us is 5 squared, which is 25. And we ask again, how many times does 25 go into 112? It would be 4 times, and that would get us to 100. We'd have 12 left over. Fair enough. And then we would divide 12 this time by the next one, which the next one in our case is 5. So 5 would go into 12 twice, which would leave us with a 2 remainder when we do that division. And then finally, the last remainder that we get, 2, we got to divide that by 1, and the final answer is always going to be a whole number because we're dividing by 1, so we should get what? 2. Now the question is, okay, that's great, I can probably follow that routine here, but where is my answer in this? Okay, because remember, I'm trying to change 487 to base 5. Okay, anybody see a familiar set of numbers here? All the answers to that are 3, 4, 2, and 2, aren't they? Okay, and wasn't that what we started with earlier today? Okay. All right. So whatever you get for those divisions that you have, okay, that is the number in base 5. Okay. Let's do another one. Let's say we want to change, let's say 688. We want to change that to base 2. Okay. So we'll change that one to base 2. So first I'm going to make a list. Okay, 1 goes into 6088. 2 goes into 6088. 2 squared, which is 4, goes in there. 2 cubed, which is 8, goes in there. 2 to the 4th, which is 16, still goes in there. 2 to the 5th is 32. That goes in there. 2 to the 6th, 64. That goes in there. 2 to the 7th is 128. That goes in there. 2 to the 8th is 256. That goes in there. 2 to the 9th is 512. That goes in there. Okay, 2 to the 10th would be 1024. So that's the last one right there because 2 to the 10th is too big, isn't it? So again, this one that we did had 4 digits because we found that 4 of the place values would go into that number. This one's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits, isn't it? Okay. So let's figure out what those digits are going to be like. So if we do 688 and we divide that by 2 to the 9th, which is 512, I said. Okay, 512 would only go into that how many times? Just once. Okay. And if I put my 512 on there, subtract, I'm going to get 176 as my result. Okay. I'm going to put my 176 on there, and I'm going to go 2 to the 8th. 2 to the 8th, they said, was 256. We got a little bit of a problem now because 256 is bigger than that, isn't it? So again, you still want to ask yourself, how many times will that go into that hole? And the answer is none. It's okay to be a 0 here. And if we have 0 here, the result is still going to be 176 then, isn't it? Okay. So we'll write down our 176 again, and now we'll try it with 2 to the 7th because maybe that'll work. Okay, 2 to the 7th is 128, and that will go into that. So I'd write down 128, and I'd go 8 and 4, be 48 left over. Okay. So when I put my 48 up there, 2 to the 6th we said was 64. The 64 is too big, so we put a 0. Still get 48. Try it again with 2 to the 5th, which is 32. That works, so we'll go in there once. And if we do 32 here, we're going to get 16. Try my 16 with 2 to the 4th. Remember, 2 to the 4th is 16. So that means it's going to go in there once, and what's the remainder going to be? 0. And so ultimately, I'm going to have a division with 0 here. I'm going to have 2 to the 3rd. Okay, 2 to the 3rd times what will give me 0? 0. Okay, I'm going to have that again with 2 to the 2nd and get what? 0. I'm going to have it again with 2 to the 1st and get what? 0. Okay, keep making square root signs. Alright, and then ultimately, I still have to have another one with 1, and I'm going to get what? 0. Okay, so once we hit a 0 remainder, okay, then everything else after that is going to be all what? All zeros. Okay. But again, you can't just stop here and write the answer as 101011. Okay, it's got to have those other zeros on there because remember, how many digits did we say there should be? Should be 10 digits. So if we write our answer 1010110000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits, and we put a little 2 down there because that's our number in base 2. Okay. All right. And again, we're going to look at some reasons why we would change from one base to another, but one thing, if you've studied any computers at all, okay, computers use binary numbers, which means there's only 2 digits available, either 0 or 1. Okay, so changing things into base 2, okay, is something that's an application of computer science. Okay, so we'll talk a little bit more as we go throughout this chapter, but ultimately that is the routine that we need to practice today. Okay, so part of our work we're going to be changing from base 10 to another base, and the other part of our work is going to be changing from some base to base 10. Okay, so that's the practice that we're going to work on for today.